We're moving to the next chapter. This is our higher order linear differential equation. Till now we are discussing chapter 1, chapter 2, chapter 3. The first order linear differential equation, that was a different form we discussed, different type of solution we discussed. Now we're going to discuss the higher order. When we say in nature, the most of the problem we are looking or we are finding, they are second order differential equation. As we have, I've given you 3 examples for that. So an undamped free vibration, d2y by dt square plus w square y equal to 0. LRC circuit, L d2q by dt square plus r dq by dt plus 1 by cq is equal to E0 cosine of wt, omega t. Then Bessel differential equation is x square y double dash plus xy dash plus lambda square y equal to 0. They are mostly second order differential equation. But anyhow, we define the higher order differential equation and then we define the second order differential equation, and we discuss the initial value problem, we discuss the boundary value problem. As initially, I give you this information. We are having 2 types of equation. You can see here the coefficient are constant. So this is a higher order differential equation with a constant coefficient. Here we can see the coefficients are variable, the function of x. So these are the variable coefficients, and the higher differential equation is the variable coefficient. If I take here an example a n x d n y by dxn plus a n minus 1 x d n minus 1 y dx n minus 1, and we say plus, I put here 3 dots, mean this is the gap which is being filled by that one. I write here 2 of x, when you have y double dash, plus a, or we just write dy d2y by dx square. You can write like that one also, d2y by dx square plus a 1 of x dy by dx plus a 0 of x y is equal to f of x. Now in this equation we can see the coefficients. The coefficients are the coefficients of this equation are a n of x, a n minus 1 of x, a 2 of x, a 1 of x, a 0 of x. These are the coefficients and they are function of x. If any one of the equation, one of the coefficient in the equation that become a variable, the equation will be with the variable coefficient. It's an nth order differential equation. We have discussed the order. The order is the highest order term in the equation. The higher order term is n, which says nth order differential equation with variable coefficients. Now you can see here the right hand side is my f of x. Now this is y equal to 0 is not the solution, so we say this is non-homogeneous. When you say f of x is there and it's not equal to 0, the equation is non-homogeneous. If we take here f of x equal to 0, then the equation is homogeneous. When this is 0, then we can see that y equals 0 is the solution, or each terms contain y, so y is the solution. This is nth order linear differential equation with variable coefficients. And we've seen if f of x is not equal to 0, this is non-homogeneous. When f of x 0 is a homogeneous. Number 2, I write here a n dny by dxn plus a n minus 1 dny n minus 1 over dx n minus 1 plus so on. We're having a 2 d2y by dx square plus a1. Now we're having here a1, get here dy by dx plus a0 y is equal to g of x. Or we say here g. So we can see it here, our coefficients are constant. So here we were having with variable coefficients. This is nth order differential equation with constant coefficient. So I can write here this is nth order linear differential equation. It's also linear differential equation with constant coefficients. Here, if we're having this g, if g is not equal to 0, this is non-homogeneous. I write here gx. Here I write here gx. It can be constant. It can be function of x, gx. And if g of x is equal to 0, the equation is homogeneous. So we are having two types of differential equation. Number one, the equation with the variable coefficients and the equation with the constant coefficients. These are our a's. When our a is here, these are our coefficients. These are function of x, we say the variable coefficient, and here our a's, they are constants. So we are having the nth order differential equation. Here is also nth order differential equation, and this is also nth order differential equation with the variable coefficient. But as I told, we are mostly having the equations which are the second order. I give you an example for that. I take an example a3 of x d3y or dx cube plus a2 of x d2y dx square plus a1 of x dy by dx plus a0 of xy is equal to 0 is third order linear homogeneous differential equations with variable coefficients. This is number 3. Number 4, I have here a3 d3y by dx cube plus a2 d2y by dx square plus a1 dy by dx plus a0 dy by a0 y is equal to, say, 0 is third order linear homogeneous differential equation with constant coefficients. If this right hand side is not 0, if this is not 0, then it will become non-homogeneous. When this is 0, it's become homogeneous. The highest order is 3 here. This term is of order 3. This is of second order. And here is of order 3 is of second order. Here we say our a3 is not equal to 0. Whenever a3 is not equal to 0, when a3 is equal to 0, then order will change. Also here we are having this an of x is not equal to 0. When an of x is equal to 0, then the order will change. Also here a3 of x is not equal to 0. So that's condition of that one. This is our third order differential equation. So similarly I can define my second order differential equation.